What makes the Greenland shark so unique? A centuries-old mystery in the crushing, silent blackness of the Arctic deep. There are living relics, creatures of flesh and blood, older than many of the countries we live in. One such giant glides through these frigid waters, a true Methuselah of the sea that has witnessed centuries of history from the abyss. This is the Greenland shark, and for decades, its incredible lifespan was one of the ocean's greatest mysteries. How can a vertebrate live for centuries? What secrets are locked away in its ancient DNA? For a long time, we could only guess. But now, science is finally giving us answers. And the truth is more incredible than we could have ever imagined. Think about this. There are sharks swimming in the ocean today that were born during the golden age of piracy. This animal is the longest-lived vertebrate on the entire planet, with the oldest scientifically aged individual estimated to be 392 years old, give or take 120 years. For a creature this massive, it seems impossible, and for centuries it was. But science has found a way to read its story, a story written not in books, but in the very tissue of its eyes. The Methuselah of the sea. Unlocking the true age of the Greenland shark was a huge challenge. Most sharks have calcified vertebrae with growth rings, much like a tree, that can be counted to determine age. But the Greenland shark is different. It's a soft-bodied creature with a cartilaginous skeleton that holds no such records. For years, all we knew was that they grew impossibly slow, less than a single centimeter per year. One of the first tantalizing clues came from a shark that was tagged in 1936 and recaptured 16 years later in 1952, having grown only a few inches. But the real breakthrough came from a truly unexpected place: the shark's eyes. The lens of a vertebrate's eye is made of proteins that form during embryonic development. These proteins are metabolically inert, meaning they don't change throughout the animal's life. They are, in essence, a perfect time capsule. Using radiocarbon dating, an international team of researchers analyzed the eye lens proteins from 28 different female sharks. What they found was staggering. The largest shark in their study, a female measuring over 16 feet, was estimated to be between 272 and 512 years old. The scientific consensus now places the average lifespan around a breathtaking 400 years. This discovery officially dethroned the bowhead whale as the longest living vertebrate. To put this into perspective, these animals don't even reach sexual maturity until they're about 150 years old. A teenage Greenland shark alive today was born around the time of the Industrial Revolution. They are living, breathing history, but knowing how long they live only deepened the mystery. How do they do it? The answer, it turns out, is written in their genes. Decoding the longevity blueprint, the quest to understand the Greenland shark's extreme lifespan has led scientists deep into its genetic code. An international effort to sequence the shark's entire genome revealed a whole toolkit of genetic tricks that seem to defy the normal rules of aging. It's not one single immortality gene, but a complex network of genes that protect the shark from the ravages of time. One of the biggest keys appears to be an incredible resistance to cancer and other age-related diseases. Studies have identified multiple copies of genes involved in the NFB signaling pathway, which acts as the body's master regulator for the immune system and inflammation. When it's working properly, it helps fight off illness and keep cells healthy. In the Greenland shark, the system appears to be supercharged, providing a powerful defense against cellular damage. But the defenses don't stop there. The shark's genome is also packed with an unusually high number of genes dedicated to DNA repair. Our DNA is constantly under assault, leading to mutations that cause aging and disease. The Greenland shark has what amounts to a highly efficient 24/7 genetic maintenance crew. Researchers found the shark has multiple copies of genes involved in DNA repair, including an altered version of the famous tumor suppressor gene TP53, which is critical for preventing cancer. This robust system ensures its genetic blueprint remains stable for centuries. It seems the secret to a long life isn't just a good start, it's having the tools to constantly fix the system over hundreds of years. Life in the slow lane. To survive for centuries in one of Earth's most extreme environments, you need more than good genes. The Greenland shark is a master of adaptation, perfectly suited for the crushing pressures and bitter cold of the deep Arctic. Its entire biology is built around one principle: conserving energy. This is most obvious in its movement. Often called a sleeper shark, it's one of the slowest moving sharks in the world, typically cruising at less than 1 mile per hour. This sluggish pace is a direct result of its incredibly slow metabolism, an essential trait for survival in the deep, cold waters it calls home. The cold itself is a lethal threat, but the shark has a chemical solution. Its tissues contain high concentrations of urea and trimethylamine N-oxide TMAO. Together, these chemicals act as a natural antifreeze, preventing ice crystals from forming in its body and allowing it to thrive in water temperatures that dip below freezing. This chemical cocktail also makes the shark's flesh toxic if eaten raw, a handy defense mechanism. Life in the abyss is a life in darkness. To navigate this world, they have evolved a unique variant of the rhodopsin gene that gives them exceptional low-light vision. Ironically, many of these sharks have their vision severely impaired. Their eyes are often colonized by a parasitic copepod that dangles from their cornea. While this sounds like a disaster, some scientists speculate the relationship might be a bizarre form of symbiosis. The parasites are bioluminescent and may act as a fishing lure, attracting prey directly to the shark's mouth. Its hunting strategy is just as unique. While its slow speed suggests it's purely a scavenger, scientists have found the remains of fast-swimming fish and even seals in their stomachs. The leading theory is that the Greenland shark is a master of ambush. It likely uses its cryptic coloration to blend into the darkness and sneak up on sleeping prey. Its teeth are perfectly designed for this, with sharp, spiky upper teeth to anchor its grip and interlocking, saw-like lower teeth to carve out plugs of flesh. It is a slow, patient, and ruthlessly efficient predator. A future in question for a creature that has survived for centuries. The modern world presents a new and difficult set of challenges. The Greenland shark's own biology, its slow growth, late sexual maturity, and low reproductive rate makes it exceptionally vulnerable to human pressures. The International Union for Conservation of Nature (IUCN) has listed the species as vulnerable. The primary threat is not targeted hunting, which largely ended in the 1960s, but accidental bycatch. An estimated 3,500 Greenland sharks are caught unintentionally each year in industrial fishing nets, set for species like cod and halibut. For a population that takes over a century and a half to reproduce, the loss of even a few mature individuals can have devastating consequences. On top of this, climate change is a serious threat. The rapid loss of Arctic sea ice is fundamentally altering the shark's habitat. Changes in water temperature and prey distribution could disrupt the delicate balance it has relied on for thousands of years. Furthermore, as a long-lived apex predator, it's prone to bioaccumulation, and studies are finding elevated levels of pollutants like heavy metals and microplastics in its tissues. This silent witness to history now faces a future where the world is changing faster than it may be able to adapt. The Greenland shark is more than just a biological curiosity. It's a living testament to the power of adaptation and the enduring mysteries of the ocean. It has shown us that the limits of life are far greater than we ever imagined, and its genetic secrets may one day offer new insights into healthy aging for our own species. From its antifreeze blood to its cancer-resistant genes, every part of this animal tells a story of survival against all odds. But its story isn't over. There is still so much we don't know. We are only just beginning to understand its reproductive cycle, its population size, and how it navigates the vast, dark expanse of its domain. The centuries-old mystery is slowly being solved, but it reminds us that the deep ocean is one of the last true frontiers on our planet. What other ancient secrets are waiting in the abyss? What part of the Greenland shark story do you find most incredible? The 400-year lifespan, the cancer-fighting genes, or its life in the crushing deep? Let me know your thoughts in the comments below. And if you want to keep exploring the biggest mysteries of our planet, make sure to subscribe so you don't miss our next dive into the unknown.